leadership. All right. So the with questions, just go ahead and put them in the chat. I'll look at them a couple of times, and of course, at the end, we'll kind of scour and make sure that all the questions are answered. Um, I have a few slides and a few demos, and so let's get right into it. I'm really excited to talk about .NET AI architecture and DevOps, which is basically what kind of structural decisions do we need to make when building software, enhancing software in order to make use of the GPT and large language model AI enhancements? And what does it do to our DevOps process and our DevOps environment um, so that we can build, test, deploy, and operate and support systems that are empowered with the large language models. So let's kind of jump in. Um, by way of introduction, my name is Jeffrey Palermo, and I'm the chief architect at ClearMeasure, which is a full service software architecture and engineering firm headquartered out of Austin, Texas. But we have engineers and architects all over the country. We do three things. We build mission critical software systems, and we also rescue failing or troubled projects, and then we also do inspections and advice of software projects and software teams and systems. And our focus is uh, very, very focused on .NET, Azure, and Microsoft platform systems. So that's kind of my world. So everything with AI I'm going to be talking about is going to be .NET. I know there's lots of every technology you can. Python is big. You can get to large language models from practically any technology, but this world is .NET, and so that's the lens that I'll be talking from. And so, quick agenda, four parts to this. We're going to talk about what the heck this AI technology is
Lay
very
down.
briefly.
Lay down in the corner.
Oh, we've got somebody we need to mute. I think Daniel and Laura can help out with that. All right, and we'll demystify large language models. Then we'll talk about a term that seems to be gaining momentum, but I think is a good theme, and I like the term AI-driven development, given we've have over 20 years of test-driven development, kind of as a term. And then we'll talk about the architectural changes and uniqueness for large language model integration with our software systems. And then we'll talk about DevOps for an AI-enabled system and how it causes the shape of our development and test, deployment, and monitoring environments to modify a little bit. All right. Um, I'll skip through this slide. If any of you are interested, I published another book in December of 2024, just a few months ago. It's on software leadership. It's called The Five Pillars: Leadership for Effective Custom Software, and it's really aimed at lead engineers to architects, and anyone who's running a software team and wants that to deliver world-class results. So, got hardcover, softcover, Amazon Kindle, and audiobook on Audible. And offer I like to give, if anyone is interested and just wants a electronic copy of the book, we have the capability of producing watermarked PDF versions. Just send me an email, and I'd be happy to get you an electronic copy on your own. And there's a study guide so that teams can kind of do a team study and have some introspective questions. So that's pretty cool. But it's all around creating clarity, establishing quality, achieving stability, and then we can increase speed and then in a iterative fashion optimize our team. So I'll just a little plug for that. So let's get into demystifying LLM and GPT AI. And I'll define them first. LLM is short for large language model, and that is the actual file that's been trained with all kinds of data and documents. Um, and it can be, from 2 GB. It's a lot of them are 4 GB, and then they get really, really, really big from there. GPT stands for Generative Pre-trained Transformer. And that's kind of the algorithm or the runtimes that's on top of these big old data files. And uh, AI stands for artificial intelligence. But if we go back to 1956, that was the origin of artificial intelligence when it was coined by John McCarthy, and he was seeking some funding for a summer program, and um, and he accumulated a small group of people, and he kind of made a hypothesis, and he made a pitch for a summer research program, and he made the conjecture that every aspect of learning or any other feature of intelligence can, in principle, be so precisely described that a machine can be made to simulate it. And that's been going on for next year. It'll be 75 years from that summer program. In 2006, there was a 50-year conference that was a big to-do, kind of celebrating that. But I go back, um, I wasn't I wasn't working professionally uh, for very few years in the 90s. I started in 1997, but the 90s AI kind of had a hype curve, kind of like we're now not as big as we're dealing with today. But if you look back at old magazines and old newspapers and publications in the 90s, you will see a lot of articles around artificial intelligence, AI. And there were two themes there. One of the themes were neural networks and machine learning, which was very, very early. But it turned out we didn't have the computing hardware to effectively do it and to bring any products to bear. So that has taken a long time. And finally, what started way back when is coming to fruition because the large language models are the fruit of the machine learning research that started several decades ago. It's finally coming to fruition. But that was being researched and being talked about in the 1990s. The other branch of artificial intelligence that was being talked about in the 90s was expert systems. And that was the originally the hypothesis that computer systems could be made with the, quote, intelligence or the ability to analyze data and make recommendations and decisions that were previously only able to be made by humans. Those are called expert systems. And I would say 30 for the last 30 years, um, as a software industry, we've kind of perfected expert systems. Those are normal today. We just call them business applications or business systems, and we have some design patterns. We have rule engines, and we have chain of responsibility design patterns. But anytime, all the banks use it now for mortgages and loans where there's a set of rules, and if somebody meets all those rules, they may be an automated approval because they've implemented an expert system where they've baked in and described the intelligence, the decision-making process for when we're pretty comfortable giving a certain person just a rubber stamp approval for a loan or a mortgage. And on the other end of the spectrum, a rubber stamp rejection for a particular loan. And then the ones in the middle where maybe there's a recommendation and it needs to be held for a person. So expert systems was the other branch of AI in the 90s, and that has come to full fruition. And we don't even call it artificial intelligence anymore. We just maybe say, hey, it's going to have a rules engine in there, or it's going to have a workflow engine, or it's going to have uh, we just call it design patterns, and we just call it business software. It's not even AI. And over my career, I've seen artificial intelligence be used to describe this original vision, which is, you know what? We can we can describe so precisely some aspect of human intelligence that a machine can be made to simulate it. And it's the dream. AI is the dream. Once we productize it, and once it's proven, once it becomes normal, we tend not to call it AI anymore. We tend to give it a product name, and we stop calling it AI, and now it just becomes normal. So expert systems is one of those. Another example is the artificial intelligence that runs in modern automobiles that knows how fast you're going, knows about the car in front of you, and can press on the accelerator or press on the brake, and we trust it to press on the accelerator and press on the brake for us, but we don't call it artificial intelligence. We just call it adaptive cruise control. So that seems to be a theme where when we're in futuristic mode or philosophical mode or thinking of the future or ooh, what could be or get excited about the future, that's when we use the word AI, and it's this very broad term, but coming back to engineering and bringing products to market, when we get specific, we tend to give it product names. And so GPT is definitely a technology that is very specific. It's a type of artificial intelligence. It's the generative pre-trained transformer, and it uses the machine learning that was being researched decades ago, and it uses the neural network algorithms that have been developed, and then software was added on top of these large language models so that a effectively a data file, and I'll show that in a minute. The large language model, which is trained, which is filled with tons and tons of documents, and these documents are labeled in a certain way. That's the pre-trained part of GPT. They're pre-trained, and then the algorithm sits on top of it and can take a prompt and then generate a response it can transform a prompt to a response based on the data that it's been trained with ahead of time. And for example, everyone's used to Chat GPT by now. Um, and uh, most of the large models are trained with, you could say it's trained with everything on the internet. And that's hyperbole, but it's trained with a whole lot of stuff. And there were some magazine articles written years ago of some of the contractors who were hired to actually classify and label all of the documents that OpenAI was putting into the GPT. And then, of course, GPT 3.5 was pretty good, and GPT 4 is amazing. And you have to take a document, and you have to give it tags or give it labels. For example, all of the large language models, they are trained with the text of Adolf Hitler's Mein Kampf. And one of the labels that you have to give a document is the attributes of that. And as you take a document, all of these large language models they tag that particular document with negative tags, right? They don't, and so every document has to have a set of tags. Is it factually verified? Is it um, is it oppressive? Is it opinion? The opinion section of newspapers, a lot of those are have been trained into these models as well, and they have to properly label them as opinion, whereas maybe another news story that's just a sequence of events of this event happened, that event happened, that event happened is tagged with news of the day, some things that actually happened. So that's kind of how all this is all this fits together, and it's really important to remember what GPT stands for: generative pre-trained transformer. So when you select a model, you are choosing to become a customer of the group that chose the set of documents to train that particular model. And we're so early, but there's more and more specialized models that are coming out, and more, and I think more and more small language models, not these really large ones, but the small ones. And I think that trend is going to continue because architecturally, it's really important to choose a set of data, which a large language model or any kind of language model, small or large, is is trained from a chosen set of data. And so they're not all the same. And it starts with the set of data that we choose to pre-train that model with. All right. So I just want to give kind of the background because it's important to understand how these things are working under the covers so that we can make use of them in our software. Okay, I want to show you some local large language model tooling um, because uh, we don't want to unnecessarily run up cloud costs just to do this. All right, I'm going to start by dragging over a browser. And I'm going to say, and this, it kind of makes you think, is this chat GPT? But it's not. What is 2 plus 2? All right. And we're running this, and 2 plus 2 equals 4. All right. This right here is Open Web UI, and it is running locally. And so there are some things where if you're going to do some AI coding, you just need to have some things running on your local computer. And you have a few options. This particular one pretty much gives you, well, it doesn't give you Chat GPT running locally. It just gives you a chat interface to any of the models. And you can see I have a number of models that are running. And Quinn 2.5 coder is, give me a C# class that can do addition of two numbers. And I didn't test this ahead of time, but anything that you're used to just typing in and getting a reasonable response from, you can use this to test out the capabilities of the different models. And this one, you can see it's running slow on my computer. And if I show you, I'm using 60-70% CPU. And some of these will trigger more usage of the CPU versus more usage of the GPU. And every now and then it gets hung up. All right, I'm not going to wait for it. Well, I might have to because it's pegging my CPU. That's another thing. Let me pause while it's doing this. Let me talk about how these things run on your local computer and what you might want to look for. So, um, all of these tools can run using your CPU only, and there is a runtime for an Intel or AMD CPU. I'm actually going to kill this because I actually don't want it running my whole. Let's see, stop. All right. Hopefully it respects my stop request because Zoom needs a little bit of this. Zoom, yeah, that's really slow. 32 billion. Oh, okay. I accidentally selected this 32 billion parameter Quinn 2.5 large language model. I had downloaded the really big one. My computer does not have enough hardware to run this one. So hopefully I can stop this because it's using up all of my CPU. So just so that it doesn't mess with Zoom, I'm going to actually kill this.
Yes, that's when you request a new laptop from your company.
Yeah, you know what? I'm actually gonna. Is the audio choppy, or can y'all still hear me okay?
Nope, you're
Oh,
still
actually,
normal.
still works
Oh,
fine and
perfect.
screen sharing
Okay.
as well.
Okay. What I was worried about is if my CPU is pegged, is it going to starve the video conferencing? So let me talk about hardware. So I do need to get a new computer, says me. But what I'm running now, I'm running a 2019 Dell Alienware desktop computer it's the R8 Alienware desktop computer. Now that's only to say that it's 6 years old. It has the Intel 9900K i9 processor, um, and it has 64 gigs of RAM. And that's been fine for me until I started doing, AI programming kind of, in the last year. And so it originally came with dual AMD Radeon video cards because my only priority was that I be able to have the number of screens that I wanted to without having to use the Intel graphics card, which would suck away the CPU. But what I ended up doing was realizing that um, the CPU bound, and actually I'm going to show you another tool so you can see these runtimes. And I'm going to pull over LM Studio. This is another one that you should have running locally. It's easy to, it's easy. Oh, this is the Quinn 5 billion parameter. That's actually very, very fast. Just to show you what is 2 plus 2. Writing C# class to add two numbers. All right. The 5 billion parameter one, it's actually a lot faster. Now, is it actually going to finish? Well, I didn't like that. Okay. So some of these, if you played around with it, you know that you have to kind of learn the model. But this right here, if I go into settings and I go into runtime, you will see that there are different engines that are available on the computer. And Llama is kind of a core to everything. We'll get to Llama. So the CPU. The CPU here is if you don't have a CUDA compatible GPU, or then you can't run this engine. Well, I do. So what I tend to do is I tend to prefer the CUDA. Uh, all of the NVIDIA RTX graphics cards, those are the CUDA. You'll see when they're discussed, they talk about CUDA cores. And so what I did, this computer originally had two AMD Radeon graphics cards so that I could have up to 6 displays without using the Intel. And what I did was I took one of those out and I replaced it with an NVIDIA GeForce RTX 3060. And the 3060, I think last time I looked, it maybe has a 140 tops, the trillions of operations per second. Now, the Copilot PCs that Microsoft came out with the Snapdragon computer and having this Copilot certified, they mandate that the hardware inside those support up to 40 tops. Well, 40 doesn't get you very far. So this RTX 3060, which is actually one of the older ones, it's just pretty budget friendly. I think Best Buy is selling them for $300, and it runs a bunch of models really well. But basically, my guidance would be make sure that you have an NVIDIA GPU that has CUDA cores, which basically it's the NVIDIA GeForce RTX series. Any that start with 30 or 40 or now the 50 that are just getting released now. The 3060 is perfectly serviceable, and a lot of the laptops, the 4070 model has been in a lot of laptops, and that one's a really good one as well. But you'll be able to see. So um, these are the engines. If you don't have a CUDA compatible video GPU, then you're going to end up using the CPU, and it's a lot less efficient, like a few orders of magnitude. Vulkan is a new one and is also supported by some of the newer graphics cards. I actually haven't dug in too much into Vulkan, but CUDA is the one that is the most popular and most prevalent out there. So this you can find this in LM Studio, and you can download models straight from here, and you can use another Chat GPT like experience just to test these out. Okay. All right, we're not pegged at 100% anymore. Okay, so let me go to another tool that you need to have running locally, and that is, yes, and that is Ollama. So here's command line, and I'm going to say Ollama list, and I already did that. Let me clean that up. These are the models that I've downloaded locally. You see that Quinn 2.5 coder, 32 billion parameters. It's 19 gigabytes of size on the hard disk. It is a data file, and it has 32 billion parameters. My computer does not have enough horsepower to run that properly. And it also doesn't have enough horsepower to run DeepSeek V3, so I haven't even downloaded it. That one is, I think, 400 gigabytes in size, but there are plenty of these models that are between 1 and 10 gigabytes that run just fine on my commodity RTX 3060 card. And so if I demonstrate that to you, let's see, I'll do Llama run, Llama 2 is very fast. You can see it's only 3.8. Actually, Llama 3.2 is actually a little bit smaller. And what's actually happening is I have the Ollama server installed locally. Just that's one of the things you want to install. Just download Ollama and it'll run a little system tray icon. And it will give you it'll give you a localhost port number web API, and then you can just do prompts right here on the command line. What is 2 plus 2? Write a C# class that adds 2 numbers. All right, there we go. So you can do that command line, and then it is Control D to exit out of there. Okay. And then okay, this is Open Web UI, and Open Web UI sits on top of Ollama. So you have to have Ollama running. Ollama is actually the engine, and this is just a chat web application that sits on top of the engine. So if I go to a new chat with Llama 3.2, what is 2 plus 3? And it's 5. Okay. So, so that's that. I highly encourage you to have that tooling installed locally. Okay. Now, Azure AI Foundry, just go to ai.azure.com and there are, just a whole lot of things that you can play with. If you've never played with any of these things, then I'd highly encourage you to just go through here and see all of the experiments and research that Azure is putting forward. Now, I also have a a few models deployed with, let's see here, a few models deployed with Azure, and I wanted to pull up. Oh, it's going to make me log. I'm not going to wait if it logged me out. Yeah, okay. I was going to show you the billing, but I don't want to go through the login again. And the billing, if you're just running local tests against Azure OpenAI, against the API, those are going to be super, super cheap. You're actually going to pay more for the storage of the models that you deploy because it's, 4 gigs a pop, 10 gigs a pop. And it's, what I see with my Visual Studio subscription that gives you, your $150 Azure credits is about $10 to $15 a month. That's basically for storage, and then maybe $1 or $2 a month for the level of actually running the AI endpoints. Because I don't do big ones. I'll show you. You want to do small ones. The big ones, and if you have it generating a ton of stuff, then you're going to use up a lot of tokens, and that's when you run up the dollars. But proper AI programming in your existing applications, there's so many features where you're not going to be generating tons of documents. You're going to be instead, getting answers to questions. So let me um, show you just briefly some of that. And so I'm not going to go into a class just yet. If you go to github.com/Jeffrey Palermo, you'll see this Git repository, and I'm actually going to run all the tests. I'm going to use my ReSharper add-in, and I'm going to run all these tests. And there are 23 tests, and every one of them do some type of AI scenario. And we don't have time to go through every one of them, but I'm going to highlight a few, and you can kind of go through yourself. And you can see these prompts, I have a chat. How old is Jeffrey's wife? Oh, 46. How old? Things like that. The Azure code test is actually reaching up to Azure with an API key. And as long as my API key is still good, yep. So I have tests running locally against Ollama, and then I have some tests that are running against Azure OpenAI. And actually, that's the one that generated the most. It was the question of, What are some things to do in Seattle? All right. So this right here, as they're running, I'll show you this one, which is pretty interesting, which verifies chat history, a thread of chat. And so and by the way, I highly, when you're learning about this and when you're learning how to interact, excuse me, interact with a large language model with code, I highly encourage you to use in-unit or X-unit, use your test fixtures and run a series of unit tests so that you can keep all of them running and just learn all kinds of different scenarios. And so this is a chat history scenario where we need to do a progression of 5 things. And this is kind of the most basic form of RAG, the uh, um, request. Now I'm blanking on RAG. Anyway, we pump information into via chat messages, and we start by saying, "Hello, my name's Jeffrey. I'm 45 years old. Not anymore. Had a birthday." And Liana is Jeffrey's wife. She's 1 year older. How old is Jeffrey's wife? Okay, so we're feeding it information just with text, and then at the end, we should be able to ask that question and get the right result. And so we can just keep our chat history, and we're adding a generic system message, only return with a single word. And so at the end, we have should assert with true, so that the first 4 tests don't actually do the assert, but the last test does the assert. So if should assert, make sure that the result is what we expected. Okay. So you because of the nature and how fundamental chat history is to a lot of these large language models, you'll want to do a pattern like that for testing. All right. Um, I'm gonna show you how you can call these, but let me just show you. Let's see, all the tests passed. Very good. Okay, let me show you how these are actually called. And it's just going to be simple. Should call Azure Chat Service. This should be the simplest form. Okay. So the library that you're going to use is Microsoft Semantic Kernel. That's the library. And you want to get that from NuGet. And then there are connectors. And you'll want to get the connectors to Azure OpenAI and OpenAI if you're using that. And then there's also the libraries for Olama are in preview. This fixture doesn't use Olama. It's going directly against Azure. And so what we do here is we use some environment variables for the URL to our service, the API key, and the model. And the runtime settings, I put them in runtime settings so that the environment variables can just be set automatically. So here's my key, and here's the URL, and here's the model that I have deployed in Azure. And those are the 3 I'm using. For other tests that use Olama, I'm pushing in some environment variables to give my local port number, and then Llama 3.2, which is what I use locally. All right, so that's the pattern that I use just for these tests so that the environment variables are readily available. And I pull them up. And then iChat completion service is the interface that you're going to use a lot when using semantic kernel. I'm going to talk about this later, but in your mind, think about semantic kernel as you think about entity framework. When you talk to SQL Server, for the most part, we don't handcraft every bit of that magic string that is a query that we send to SQL Server, because that string could have a whole lot of semicolons and could have like 10 different segments that we want the database to do before it comes back. And then it comes back either as a string or a result set, or all kinds. And then Entity Framework, it kind of builds that for us. And then on the way back, it takes the response from SQL Server and it makes it available in code. Think also of HTTP client. We don't handcraft the string that happens to be an HTTP request with the different headers, with the application type, with the body section, all the different things that need to go into a properly formatted string that is an HTTP request that can be sent to a web server. And of course, the web server sends back an HTTP response. We don't look at that with our own eyeballs. We want a browser to decipher that for us, or we want the C# code and the HTTP response to parse that out for us so that we can get back just certain sections of it. Or if we want to save off a cookie that we were given, we can do that because that's responded as well. So think of those libraries as in the same class. In your mind, put semantic kernel in the category, same category as you think of HTTP client and as you think of entity framework. We are not going to handcraft by hand, painstakingly, the entire string that is a large language model prompt. And we're not going to parse back everything that I say the large language model, really it's OLAMA. It's the OLAMA runtime. And I'll talk about that. But so we're going to construct it, passing in the model that we chose, the endpoint, the API key. Then we're going to call, okay, get chat message. What color is the sky during the day when there's no clouds? And we want to push the result. And I'm asking for a single word response with no punctuation. So I'm just going to do a shortcut assert, and you better respond blue. Okay, so let me run that one. And we got down blue. Okay. This large language model happens to give me a capital B, but we need to learn the model that we're using because some of them are different. Okay, so this is kind of just the code for how we call it with C#. And the only other code that you're not seeing, let's see, iChat completion, new. No, that's everything. That's everything. There's some, yeah, it is so simple these days with semantic kernel. So we're going to go deeper into it, but I just want to encourage all of you. Those are the basic tools that you need to have installed locally. Okay. All right, so what's actually running? I talked about SQL Server Entity Framework. This is what's actually running under the covers. With OLAMA is the runtime. It is a process that's running on my local computer. And if I went to Process Explorer, I would see that it's running. And then there is a file that is 4 GB in size. And so if I go here, go to blobs, you're going to see that, that Quinn 2.5, 32 billion. I can tell with the 19 GB size, that's the one. And then I think that one is probably Llama 3.2. But you essentially put into an environment variable when you can configure OLAMA where you want it to download. And you absolutely need a drive that's large enough because these are really, really big files. And so it literally is a file on disk. Okay. And then you have your running OLAMA process that operates, that connects to the file, that loads, enough in memory to be able to access it. And then it provides a web service endpoint on a particular port number. And then our .NET application through the semantic kernel library can call that address. So OLAMA can literally be running anywhere. NVIDIA has the Jetson little computer system on a chip computer with a kind of a CUDA core RTX GPU built into it. And so it runs a Linux operating system. So if you take that and then you plug in a terabyte, USB drive, one of the fast solid state USB drives into it, well, now you can have an OLAMA server and you got plenty of space and put it on your network, give it a static IP address, and and install the Linux version of OLAMA onto that little computer. Well, now you have a large language model server that could be running on your desk, plugged into a little 5-port switch with your computer, and you don't even have to tax your local computer. And you could do all the testing you want because semantic kernel, just like Entity Framework, it just needs a connection string. It just needs to know where to connect. And so I wanted to draw that parallel because we're used to a database being this big honking MDF file and it has to be on disk somewhere. And we're used to running SQL Server, whether SQL Server Developer Edition or SQL Server Express. We're used to installing this server that is up and running and it has an address and the port number has to be accessible. And then our code through Entity Framework just needs to be able to reach out to wherever it's running, whether it's running locally or whether it's running on another computer on the network and do its thing. So architecturally, those are similarities that I hope simplifies how to get a development environment set up for doing AI programming. All right. Okay. Just I just want to answer a question. What VS extension is he using to get that parameter info in the? Okay, yeah, I am running ReSharper. Been using ReSharper since 2003, and I also have GitHub Copilot, but ReSharper is what does kind of all the pop-ups and shows everything. Okay, highly recommend it. All right. Now let's move on, and we'll be moving quickly to AI-driven development. I'd encourage you to look at episode 317 of the Azure and DevOps podcast. I interviewed the founder of Scrum, Jeff Sutherland. Now he was a co-founder um, with scrum.org, but originally in the 70s, he kind of pioneered the process that became the Scrum framework. And it was really interesting because he talked about the death of Agile. He talked about where all the Scrum trainers kind of went sideways and cared more about the process than yielding effective software teams. And um, and he used a term that I hadn't heard before, and he used the term extreme agile. And he says that extreme agile is Scrum and AI. And when he's saying AI, he's talking about GPT and large language models, this generation of AI. And he says by 2030, teams will need to be 30 to 100 times faster than they are now, or teams will be 30 to 100 times faster. So if our team is not 30 to 100 times faster, then we're going to have a hard time competing. And there's two themes that I want to talk about just to start the conversation or the thoughts in your head. One theme certainly is using large language models in your software to automate features that might have been too difficult before, things where you need the comprehension of of natural language. But I want to talk about one other theme, and that is productivity. How are we going to use AI for productivity? Regardless of putting a large language model to use in our software, we have to be productive with it. The concept that has been talked a lot about in the past is coding forward. And there was a question just about ReSharper. ReSharper is certainly a way where, and I don't have hard numbers, but I've witnessed it firsthand. Teams that are using ReSharper to help them code forward get the intended behavior from the brain into C# so much faster. I would say 10 times faster, easily, than just using regular Visual Studio Intelligence or typing things out. Same thing with refactoring. GitHub Copilot is too new to, to be there yet, but GitHub Copilot is going to be one of those tools where people who master it are going to get those orders of magnitude increase and not magically writing code for us. That's the pipe dream. But if we've already figured out how we want it to lay out and it's in my brain, then the question is, how fast can I get it from my brain into C#? That's what we're talking about. And remember, these large language models were trained with, so many billion parameters. Those are aspects of human intelligence so that that machine could simulate human intelligence. There is no actual intelligence. And so don't think that GitHub Copilot excuse me, is just going to magically design and build the software just given bad requirements that you were given. No, it's still the job to move from bad requirements to good requirements, then make the right design decisions, then with the chosen design, shared understanding in our heads, on a whiteboard, on a pen and pad, whatever it happens to be. And now it's in our head. And now we need to get into C# as fast as possible. That's where these tools are going to shrink the time frame between the clear understanding in my brain and that understanding being in C#. You cannot skip the step where you have the clear understanding in your brain. It's not going to work that way. Don't expect to not do the proper design and then have Copilot or any other tool that comes out just magically design it properly and have it work. It's not going to happen. Okay. But coding forward, so think about that and start studying these available tools. And ReSharper and Copilot, those are the two right now that I'm really leaning into, and I encourage everybody to really lean into. They're ready for prime time. Other tools are going to come out, and that's awesome. Fantastic tool. I mean, the next decade is going to be this massive renaissance in developer productivity tooling, and we're going to need to master them. But ReSharper's been prime time for decades, and it's built in more AI functionality. So ReSharper and Copilot are the two that I highly encourage you to absolutely master so that you can code forward as fast as possible. The second that we're going to have to get really good at is architecture standards, design patterns, and consistency. Copilot, when you start, file a new project, it gives you suggestions based on the broadness of what's in GitHub, but it may not be the patterns that you want. And so your code base that's in your solution needs to actually be standardized and have clear design patterns and be consistent throughout. That really empowers Copilot to suggest larger bits of code, larger and larger, that are the same as the other code that you already have because you already like the format. You've implemented standard architecture patterns and ways of coding in your Visual Studio solution. So when Copilot emulates that, it's good. Okay. If you don't like the code that's in your current Visual Studio solution, then Copilot's gonna do a little bit more than IntelliSense, but not much. Okay, so on your Kanban board, I just wanted to stress real briefly, and I've talked a lot about this over the years. You need to make sure that you are doing technical design before you try to put down some code. Um, do not skip the technical design because this AI generation of productivity tools are not going to help you. They are not going to do design for you. You have to actually intentionally make sure that you are doing technical design. And you need to establish those design patterns early. I think that the role of architect is probably going to be more and more important in the era of AI-driven development because none of the AI tools are going to get us much unless we do have clear architecture patterns and standards implemented in the code base. So just want to do that. All right. Now let's get back to actually integrating a large language model into our software. And I want to go back to data access. In our Visual Studio project structure, if you followed my writings and talks on onion architecture over the years, I've always suggested that Entity Framework and data access be its own project because there's a group of NuGet packages that know about SQL Server and know about data, and those are inappropriate for being package dependencies in other projects. You want your business logic and the core of your application and your entities to not have to have a reference to NuGet packages that are SQL Server or web service or any other interfaces to the outside world. You want them to be, just code. And then we have data access, which has all those dependencies for SQL Server and Entity Framework and how to save and retrieve data. Well, guess what? It's the same pattern. If you look in the Gang of Four design patterns book, you'll see a pattern called gateway. If you've never heard of that, go research the gateway pattern, because your data access project, you can think of it as a data gateway or a data interface. It has an interface so that the user interface can or the client that a user is using can go through the IOC container, the services collection in modern.NET, and it ends up invoking our data gateway to SQL Server. Same thing with large language model. We want a project, and you can call it LLM Gateway. It is a gateway to our large language model, and you can use the services collection, your dependency injection, to switch between Olama locally or Azure OpenAI running in Azure. But either way, it's a project that has the semantic kernel dependencies and the other libraries like that will crop up that you don't want cluttering any other project in your Visual Studio solution. So it's a very similar architectural pattern. And so make a new project in your existing application, call it LLM Gateway, and reference semantic kernel and some other libraries, and implement an interface and register that interface with your dependency injection, your services collection in .NET, and then start using it just like you do data access. And let me flow through one other concept and then we'll end it. But I'm going to go back to Visual Studio. A lot of times the large language model can't do anything but interpret English, but we want it to do really interesting things. So I'm going to, where is my tool invoker? There we go, tool injection scenario. Okay. Here we go. I'm going to ask it the question, is Grandpa's age older than Liana's age? Well, Llama 3.2, or even as GPT-4, has no idea who Grandpa is, how old Grandpa is, Leon. But you know what? We might have a database of people and ages. And so our system can register a tool just with some settings that says, hey, you know what? Function choice provider behavior auto. We are going to import a plugin, demographics kernel function. You can call it whatever you want, but I called it that. This could be an entry point into a SQL Server query or whatever you need to. I've just hard coded some text, but here's something. I have kernel function and I have a description in English so that the large language model can understand it. And armed with that, I'm just going to run it once, and it is going to parse my question, realize that it needs to call a registered tool. It's going to call it, and then at the bottom, it's going to give me back the answer, yes. Because the question was, is Grandpa's age older than Liana's age? Single word answer, please. Okay. So this is the magic, not just calling it and asking it questions. I don't really care. I want a small language model here. I don't need the whole internet to be able to ask it questions. I need determinism. I need processing of English language. And so if I can process some English into a function, that's interesting from this pattern. And what we do, and let me just show you what's happening first, second, and third, and then we'll end it. Because this is the true power of integrating these large language models into your system. You want it to be able to understand English, parse it into code, and then call other parts of your existing system that are already there. So I'm debugging here, and this is what's happening first. I just wanted to stop it. I'm going to hit F10, and now we go to this next one. Okay, this is one line of code into chat service, get chat message, and then F10 again, and it pops me over to the breakpoint. It's gonna parse it, and then now we're calling our function. That's the next thing that happens with the name of Grandpa, and we're responding back with in the name of Grandpa. We're responding back with 81, and then it gets called again with Liana, and we go through here, and we're going to respond back with 46. And now we come and we're just going to do the for loop, and what's the content, and it's yes. Okay, F5 to get out of this. Now I have done console logging so that you can see what's happening. And I want to walk you through what's happening with this because it's actually multiple calls to the large language model. The first one, like I said, do you really want to draft from scratch the entire prompt? I don't think so. So under the covers, this is the prompt that's being crafted, and it's a slightly different format depending on what model you use. So I, as a user, said, is grandpa's age older than Liana's? And my tool mode was auto. The provider is Olama. Here's where it went. And then the assistant, which is Olama, comes back and says, okay, I need a function call. And I need get person age to be called with grandpa, please. And I need Liana get person age to be called. And that's the response. That's the first response, and it took 224 tokens. So if you're going to Azure OpenAI and seeing how much it's going to cost me, you'll need the number of tokens. Okay, so that happens. So now inside the semantic kernel library, we are going to call get person age with grandpa, and we're going to get back 81. Then we're going to call get person age with Liana, and we're going to get back 46. Now we, as the role user, are going to issue, well, semantic kernel is doing this under the covers, is issuing another prompt back to the same model with the same with the same history, and includes all the old history. It says, first, we asked, is grandpa's age older than Liana's? Then the assistant came back and said, okay, I need these tools. And so then we're going to come back, and the role is tool. And the contents is, hey, the function call with grandpa was 81. The function call with Liana was 46. And so now the result that's going to come back from the role assistant is now yes. And so that second round trip through Olama to our large language model took up 157 tokens. So you add that with the 200 and something, and then you get your total token count. And with that type of testing, you can do your budgeting for how much it would cost you at scale for Azure OpenAI. And then you get back the answer. Okay. So that's kind of how it goes inside .NET. And you can see how simple the code is. So as we go back and kind of finish up with our slides, this is kind of a scenario where you would design a gateway pattern. So I'm gonna stop it here and be respectful of time. I'll hang out and answer questions. Daniel, we need to stop right at 1. Do you need to close out?
Don't need to stop right at 1. I would say the next 5 minutes or so.
Okay, fantastic. So one thing, let me go through this scenario because I did a lot of work on a piece of software for online livestock auctions while county fairs were locked down in 2020 and 21 and some in 22. And these were livestock auctions of FFA and 4-H. So they already raised the animal. They needed to sell the animal, but they needed to do the auction online. And so at the time, a multi-bid scenario was really difficult. But with a large language model that understands English, it actually becomes pretty simple. So let me walk you through it. Step 1, inside the user's browser, the user is going to browse available livestock for bid. Then one of the big sponsors who loves, winning the grand champion steers, or maybe a breeding company, a livestock breeding company that wants the best animals, they would issue a free form just English instruction, and they could do it via chat, they could do it via voice, and the instruction may be, hey, bid $5 a pound on all the champion steers. That's a very abstract thing. I mean, without large language processing, you're going to have to like painstakingly search through. You're going to have to find the ones that actually did receive a champion award. Then you're going to have to go and see how much they weigh, do a calculation, $5 per pound, and then actually put the dollar in there. But with a large language model, we can just issue that over to our code that's maybe happen to run in Azure App Service. So think of a web service call. Think of Blazor WebAssembly doing a web service call over to your .NET app running in Azure App Service, and that code is going to register some tools with semantic kernel to do calculations and SQL Server searches. Then we're going to issue the prompt to Olama or Azure OpenAI, whatever happens to be. So when we do that, that's number 4. Number 5, Olama is going to load, or Azure OpenAI, load the large language model selected and then parse the prompt and call the registered tools. In this case, there's a few things that a large language model can't even hope to do on its own. And so number 7, it's gonna filter out to only champion steers. How do we do that? We jump over to SQL Server. There's a tool, C#, that knows how to call our database and looks for all of the items where the appropriate field that designates champion, or the appropriate tag that designates champion. Okay, let's actually query our own database. Let's go to a tool, a C# tool that's registered, and do that query, return the list, and then come back. And then we need to the another tool registered will be a calculator. So we need to calculate the bid. And so that tool would be called once for each of the results to get the weight and then multiply that by the bid price that our large language model parsed out of this natural language sentence. All right. And so we get the actual bid price. Then that's into the line. So we kind of rewind the stack all the way back over to the user's browser. And now the user looks at a screen with a list of animals and a list of suggested bids for confirmation. Because again, this machine is just a machine. It's not a decision. So there's no actual intelligence here. So the user needs to look at, okay, these are the bids that you're preparing for me, and glance at them. If I like it, I hit a button that says go, and then user approves the bids. And now with a list of bids, well, now regular code can just quickly run that, which ends up doing some insert statements in SQL Server to do some bids, and then we display some successful bids. So just by integrating a large language model into an existing piece of software, we can accomplish features that are previously very, very difficult or impossible to envision how we would possibly do that. And it's not that we're choosing a model that happens to have been trained with a whole bunch of data. All we're doing is using it for understanding natural language processing, and then using the semantic kernel library to integrate with other functions and other parts of our software system that are already there. And it's hugely powerful. That stuff is prime time. That stuff is ready to go right now, regardless of what may be possible in the future. Those types of scenarios are available right now. And the beauty is your existing DevOps environment doesn't really have to change a whole lot. You're still focused on quality. You're still doing pull requests. You're still writing automated tests. You're still deploying to a test-driven development, a TDD environment, a UAT environment, a prod environment, because just like an application that uses a database and has to have specific tests to make sure we're interacting with that big database properly, we have another significant dependency. It's a large language model and a runtime, and we need to have appropriate tests to make sure that we're interacting with it properly. So I hope that was useful. We can close up now and switch over to questions, Daniel.
Yeah, I did see you had one question just now in the chat.
Perfect. In the example of the bidding, you would have to know that champion is a term that you'll have to provide a tool for, right? Yes, you're exactly right. And to provide a natural language interface to our users, we have to know what the natural language is, and we might want to give it some some various options, or give it some hints, because we obviously can't take every request under the sun. Like if someone were to say, hey, bid a whole lot of dollars on the animals that I like. Well, okay, that's just not going to work, right? So we're going to have to analyze and figure out the common scenarios that our user base really wants to do. Like for example, that exact scenario is what people did in person. They walk into the show barn and they walk up and they get their number, and they tell one of the workers that's running the auction right off the bat, all right, I want you to put a starting bid for me right now of $5 per pound on all of those champion steers. Even before the auctioneer starts barking, I want you to put on a pre-bid $5 a pound on all the champion steers. And the assistant says, got it. All right. So if we can describe the thought process, the sequence, that aspect of intelligence that auction worker went through to calculate the appropriate bid, and figure out which steers that it needs to go on, well, then we can create a machine that simulates that aspect of intelligence to do it for us, which goes back to the original hypothesis of artificial intelligence that John McCarthy came up with in that summer study in 1956. All right, another question. How big was the impact on infrastructure cost in that example project related to the large language model attachment? How big was the impact infrastructure cost? Okay, so my actual test environment has been running at less than $15 a month for those tests that I showed. In the example of the multi-bid,
The editor is going to be VS Code.
that
Apart from
oh, somebody's mic is on. That didn't get implemented because it was too hard with the technology of 2021. But if we were doing that now, which by the way, all those auctions have gone back in person. So, but if we're implementing it today, that's how I would implement it. And how much would it cost? I would expect it to be one of the most inexpensive usages of those Azure OpenAI services, because we're not asking it to generate a ton of text, which are tokens that we get billed by number of tokens. We're not asking it to generate a massive document with, thousands of tokens. We're just asking it to parse what we gave in and just, we're in the hundreds. We're in the low hundreds of tokens. So this type of integration is going to be your less expensive method than if you were trying to do some, document generation where you're asking the large language model server to give you just paragraphs and paragraphs of text. And that's those scenarios are less deterministic anyway. The scenario that I showed you is one of the most deterministic. You could do some automated integration tests and automated full system acceptance tests, and you could lock that down and be absolutely deterministic. Okay. I think, the GitHub repo, we included that in the chat. Yes, thank you. GitHub.com/Jeffrey Palermo AI semantic kernel. Perfect. Okay. Well, thank you very much.
Cool.
Thank you
Thanks
very
for
much.
the questions. Yeah, thank you, Jeffrey, for awesome presentation. I have personally not messed with local LLM stuff, so it was cool to see that running.
Yeah.
I don't think I shouted this out, so thank you everyone on the San Antonio side who came out to the in-person event in January. And if you are in either the San Antonio or the Austin.net user group on Meetup, you will get all those links and stuff I put in the chat in your email. So please do fill out that feedback form for Jeffrey. There's only one required question on there. And hit up Ashish or myself if you would like to speak. So,
And
yeah.
I did put my email address in the chat for those who want
Yeah.
the free electronic copy of my book.
Cool. Thank you for that. And hopefully see some people at the conference in May. Otherwise, I'll see everybody in March for our next session. So thanks everyone for joining. Thanks, Jeffrey, for presenting.
My pleasure. My pleasure. Thanks so much for the invite.
All right. See y'all. Enjoy the cool weather while it lasts.
Thank you, Jeffrey. Awesome.